Noisy air conditioner seems like a simple problem. Replace it with a newer, quieter model and you're done, right? Maybe, maybe not. The real issue might be poor insulation, outdated windows, or even something unexpected, like the strain of severe weather. By focusing solely on the air conditioner, you risk overlooking the interconnected systems that create comfort in your home. And you might waste money on a new unit only to see it develop the same problem after a short time. This is the essence of systems thinking, a mindset that examines how different elements interact, often in surprising ways. Instead of zeroing in on isolated symptoms, systems thinking reveals a web of relationships influencing both problems and opportunities. Imagine spotting issues with a tree in your yard. Its leaves are dotted with spots, and you could spend hours trimming, cleaning, or even painting the leaves. Yet this would only address the symptoms, not the root cause. A tree is a system, and the issue often lies quite literally with its roots. Addressing the nutrition or health of the roots often results in healthier, vibrant leaves over time, with far less effort than focusing on the leaves themselves. Systems thinking works the same way. By addressing the root of the problem rather than its symptoms, we create more effective and sustainable solutions, sometimes even faster, cheaper, and requiring less effort. While this perspective originated in fields like biology, engineering, and management, its core idea is simple: everything is interconnected. No part of a system exists in isolation. Systems overlap and often influence each other in ways we don't immediately see. Think of astrology, for example. Ancient astrologers mapped the cosmos to understand how celestial movements might shape earthly events. Whether or not you believe in astrology, it offers a useful metaphor for recognizing patterns and relationships across seemingly unrelated domains. Interestingly, we now know that celestial bodies do influence each other through forces like magnetic and gravitational fields, phenomena that our ancestors intuitively perceived long before hard scientific data confirmed their insights. Now, what is a system? In my videos, I choose my words carefully to establish a clear baseline terminology, ensuring that you have the context needed to understand the concepts I'm conveying. When I use the term system, I'm not referring to computers or technology. A system can be anything: process, an environment, a network of people, or even natural forces like weather. Systems are everywhere, and they frequently overlap and interact in unexpected and unpredictable ways. Consider your noisy air conditioner again. Applying systems thinking involves picturing concentric circles radiating outward from the immediate problem. Let's start at the outermost circle, the Earth itself. Today's more acute weather patterns, like extended heat waves and sudden temperature swings, could be straining your air conditioner. Maybe it wasn't designed for such extremes, and that additional strain could cause wear and tear, leading to noise. This discovery might prompt you to explore whether the unit specifications align with current conditions. The next circle could involve the local environment. Perhaps trees that once shaded your home were removed, increasing direct sunlight and forcing your air conditioner to work harder. Or maybe the local power grid struggles during peak hours, causing fluctuations that affect air conditioning performance. Identifying these possibilities lets you ask better questions and uncover root causes you might have missed instead of just focusing on and addressing symptoms. Moving closer, the next circle might include your home's design and structure. Poor insulation or leaky windows might be making your air conditioner compensate for lost cool air. Addressing these issues could not only quiet the unit, but also lower your energy bills. Finally, the innermost circle, your usage patterns. Perhaps running the air conditioner continuously instead of using a smart thermostat to regulate it has caused premature wear. This personal behavior, while part of the system, is just one of many elements influencing the overall situation. Each circle brings new insights. Some might not feel immediately relevant, yet systems thinking isn't about finding a single silver bullet. It's about understanding how related and unrelated factors intersect. By seeing these connections, you can evaluate what matters most and where to intervene effectively. Let's explore a larger example. Imagine addressing urban traffic congestion. Traditional approaches focus on isolated fixes, like adding more lanes or adjusting traffic lights. Systems thinking takes a broader view. It considers housing policies, work from home trends, public transit availability, and even psychological factors like how commuters perceive travel time. Each of these elements operates as its own system, overlapping and interacting in complex ways with the others. Solving the conjunction problem requires navigating this complexity rather than trying to fix one piece in isolation. The principle of interconnected systems is vividly illustrated by history. Consider China's Four Pests campaign in the 1950s, which targeted sparrows, mistakenly blaming them for eating grain. The campaign succeeded in decimating the sparrow population, and without sparrows to control insect populations, locust swarms exploded. This ecological imbalance contributed to crop failures and played a role in the Great Chinese Famine, one of the worst in human history. Similarly, in medieval Europe, efforts to eliminate rats unintentionally worsened the spread of the bubonic plague. By targeting rats without addressing the fleas they carried, people disrupted one part of the system while leaving the true vector unchecked. The result? Devastating epidemic that killed millions. Now consider how these lessons apply to AI. Imagine a company implementing an AI system to optimize hiring by screening resumes faster. On paper, this seems like an efficiency win. However, without examining the system holistically, the AI might inadvertently reinforce biases rooted in the company's narrow hiring goals and historical data. This could systematically exclude highly qualified candidates who don't fit the historical mold, damaging the company's hiring efforts, public reputation, and even legal standing. All unintended consequences of a well intended yet overly narrow focus. Whether it's ecological management or AI integration, systems thinking teaches us to pause and consider the ripple effects of our actions. What seems like an isolated fix can backfire disastrously if we fail to account for how our interconnected systems influence each other. Now, here's your challenge: apply systems thinking to your next decision. Before jumping into action, pause and ask, what else might this affect? What connections am I overlooking? Which wider systems are in play? Share your discoveries. Did you uncover unexpected relationships? How did that change your approach? And if you found this helpful, stay tuned for more insights on building adaptive, resilient organizations in the era of AI. Thanks for watching.